Hello students, welcome to Tuteetute. So in this video we will see recently completed AEE examination measurement questions. Previously we have did other subject videos also. So now in this video we will see all the measurement subject questions. These questions will be useful for your upcoming GATE examination, assistant engineer examination, any other PSU examinations and polytechnical lecturer examination also. Okay, so let's see the first question from measurements. A dynamometer type wattmeter is used to measure power of a room heater. Which option is correct? Okay, so they have mentioned dynamometer type wattmeter. They were just using for some application. Okay, so leave it whether that is a heater or any other application. They are using for some application dynamometer type of wattmeter. So see the options what they have given. Current in the fixed coil is lower than the current in the moving coil. Okay, so they have asked about the coil currents. So in any dynamometer type of instrument, so there will be current coil and potential coil or pressure coil we used to call. Okay, so current coil is also called as fixed coil. Potential coil is also called as moving coil. Okay, so now what they are asking, so current, we need to check the currents in current coil and potential coil, and that means fixed coil and moving coil. Okay, so we need to test means first we need to know where these coils have connected. Okay, so in any of the dynamometer type of instrument, where current coil is connected, where potential coil is connected. Okay, so these questions are also important for us. So generally current coil or fixed coil is connected in series with load. Okay, so in series with load, that is the current coil. Okay, so potential coil, otherwise moving coil, where it will be connected across the load. Okay, so across the load. Okay, so that is the potential coil. Okay, so this is the two connections of coils. Okay, so current coil is connected in series with load, potential coil is connected across the load. Okay, so whatever we are connecting in series with load, that should have low resistance. Whatever we are connecting across the load, it should have high resistance. Okay, so these are the 2 points we need to note down. Okay, so low resistance, so definitely high current. Okay, so high current. So high resistance, low current. Okay, so these coil have designed like that. So the current carrying capability of the current coil is higher compared to potential coil. Okay, so that's what in our options we need to see. Okay, so current in the fixed coil is lower, wrong option. Okay, so current in the fixed coil is same as the current in the moving coil. We cannot confirm this one. Okay, current in the fixed coil is more than the current in the moving coil. Okay, so this is the correct one. Okay, so current cannot comment on the relative currents in the moving and fixed coil. Okay, so whenever they have not mentioned any application, okay, if it is at the designing stage only, then this option is correct. Otherwise option C is the correct one for this one, after option third. Okay, next question. An ammeter has a range of 0 to 10 amperes with an initial resistance of 0.1 ohm. In order, okay, so internal resistance of 0.1 ohm. In order to increase its range to 0 to 30 amperes, we need to add a resistance of. Okay, so this model of question, any exam, okay, so GATE, engineering services, or any AEE or AEE examination, polytechnical lecturer examination, SSC junior engineer examination, any type of examination, this model definitely will be coming from ammeter. Okay, so this is, they have not mentioned anything. This is DC ammeter. Similar to, they can ask about AC ammeter also. That means this is PMMC. Okay, this is PMMC. They may ask from moving iron type of instrument also. Okay, see what they have given. So old range, directly we have to write down. Okay, so old range, what is old range? 0 to 10 amperes. What is the extension range? We need to increase its range from 0 to 30 amperes. New range is 0 to 30 amperes. So what we need to do? We need to extend its range, right? So ammeter, where we have to connect the resistance. some other resistance we have to connect. Where we have to connect? The resistance for any ammeter, external resistance, okay, or shunt resistance, where we have to connect. If you see the diagram, okay, so this is the meter resistance. In parallel to this or in shunt with this one, we have to connect RSH. That is the shunt resistance. This all combination will be in series with load. Okay, so in this one current is ISH, in this one current is IM, like this. Okay, so this the shunt resistance, where we have to connect? In shunt. Okay, so in shunt with the meter we have to connect. Okay, in shunt with the meter we have to connect. Remaining two options directly we can eliminate. Okay, so in shunt we have to connect. Now what is the value? Okay, so we need to know the value. RSH is equals to RM into M minus 1. Okay, not into RM divided by M minus 1. Okay, so whatever you are connecting across, okay, so this should have low resistance, because higher current has to flow in this one. Our application is to bypass higher currents to this one. Okay, so RM, first we will calculate M value, multiplication factor M is equals to 30 divided by 10, that will be equal to 3. Okay, so RM, what is the value of RM? 0.1 divided by, so 3 minus 1, 3 minus 1 is 2. So if you calculate, what is the answer for this one? So 0.05, option 1 is correct. Okay, so this model of questions definitely, okay, simple model and same calculations only how to do, just values only will be changing. Okay, next question. An average reading multimeter reads 5 volt when fed with a square wave symmetric about the time axis. For the same input, an RMS reading meter will read. Okay, so this is a little bit tricky question. See what they have mentioned. Square wave they have mentioned. It is symmetric about the x-axis. Okay, so this is the square wave. We don't know what is the maximum magnitude. Okay, so but that meter is reading. See what they have mentioned. The meter itself, average reading multimeter. Average reading multimeter. So this is, what is average of this one? It is symmetric about x-axis, means generally average value is equals to 0. But why it is showing 5 volts? Why it is showing 5 volts? Because it is calculating for half cycle. That's why we need to consider. Okay, so the half cycle average value. Okay, the half cycle average value. So whatever we got here completely, that is 5 volts we need to consider. Okay, so average equal to 5 volts. Now the same thing only. Okay, so for the same input, an RMS reading meter will read. RMS meter, what it will read? So RMS meter means root mean square. Okay, root mean square. So that means what we have to do? This signal first we have to square. This signal first we have to square, then have to calculate the mean, then have to calculate the root of that. Okay, see for example it is the 5. We have already the average value from here to here is 5. So this value is 5 now. So if you square this one, okay, so first what we have to do? Square. Okay, so if you square this one 5, so it will become 25. So minus 5, it is minus 5, it is symmetric, right? So this is minus 5. If you square minus 5, then also you will get 25. Like that, from 0 to infinity you will get 25 only. Only one completed. Okay, then we have to calculate the mean. Mean means for the entire period, if you see, okay, so generally if one is 10, another one is 0, then what is the mean of this one? So from here to here 2 seconds, for example, mean is nothing but 10 divided by 2. We have to calculate like that. Okay, so average will be 5, we will be getting like that. Okay, so that is general, but here everything is 25, so mean is also 25 only. Okay, so then we have to do root of that. Okay, if you do root of this one, again you will get the 5 only. Okay, so like this, in signal point of view you have to do this calculations. Okay, so nothing related to our meters, we need only average and RMS calculations only. Okay, next one, which bits can be used for measuring relative permeability? Okay, so see here, someone may confuse definitely. Okay, permeability it is, it's not permittivity, relative permittivity. Permittivity, what is epsilon? It is permittivity. Okay, so permittivity. Okay, so what is mu? What is mu? Permeability. Okay, so permeability. Okay, so I'm not giving the differences, I'm just giving which bridge can be used for this and which bridge can be used for this. Okay, so permittivity, okay, so epsilon, so it is the property of a capacitor, that means dielectric material. So for the calculation of capacitance, which bridge will be used? That bridge can be used for this one. For the permittivity calculations, which bridge will be used? Shearing bridge will be used. Okay, so now permeability is the property of inductance. Okay, so inductance, inductive property, it is inductive material property. So for the permeability calculations, which bridge will be used? See here, Wheatstone bridge only resistance, Kelvin's double bridge only resistance, remaining Anderson's bridge. Okay, so Anderson's bridge generally used for accurate. Okay, so accurate inductance measurement. Okay, so accurate inductance measurement. Okay, so in our subject we will not study about permeability calculations anything. We will see only inductance and capacitance, mutual inductance, and some of the other resistive calculations only we will see. Okay, so but inductive or permeability, not inductive, permeability calculations we don't have in our syllabus, but they just ask in this one. Okay. So next, which bridge is used to measure frequency? Okay, so Wien's bridge directly. Okay, so is it possible to measure using Maxwell's bridge? Possible only, but perfect bridge is Wien's bridge for the frequency measurement. Okay, so all these bridges, using all these bridges, we can measure the frequency because one capacitor is present, one inductor is present. That's enough. Bridge resonance is possible. We can measure. So using these all bridges in Maxwell's bridge means Maxwell's inductance capacitance bridge. Using that bridge we can measure frequency, but it will take more time to get the bridge balance condition. That's why we don't prefer. Okay, so perfectly designed for the frequency measurement. Which is that bridge? Wien's bridge. Okay, shearing's bridge is used for what? For the capacitance measurement, for the epsilon. Okay, so permittivity calculations, and so distance also we can calculate between the parallel plates. So between the parallel plates we can find out dielectric loss. Okay, so dielectric loss also we can calculate. See, measurements is very simple subject and we have to read each and everything only. Okay, so not only in this. Okay, so in interviews, if you are attending some interviews about any PSUs, okay, so measurement subject we have to read perfectly. Okay, so anyway, Anderson's bridge will be used for accurate inductance measurement. Okay. Next question. Two channels of a CRO are fed with two signals in the XY mode. An ellipse with major axis aligned along the Y axis is observed. The following inference can be made from this one. Okay, so whatever they have mentioned, from that we need to know our Lissajous figure first. Okay, see what they have given. It is XY mode of operation. Okay, it is an ellipse with a major axis aligned along the Y axis is observed. Major axis is aligned along the Y axis like this. It is, they have not mentioned the direction, leave it. Okay, whether it is clockwise rotating or anti-clockwise rotating, they have not mentioned anything. We got the Lissajous figure like this. Okay, so now what they are asking, the following inferences can be made. Two signals are periodic with the same amplitude but different frequency. See, two signals are periodic. That means periodic means so they both having same period. Okay, same period with the same amplitude but different frequency. Okay, so any of the signal, for example, sine x, it is XY mode, right? It is XY mode, so we'll consider like this. Okay, so a sine omega t plus phi, we will consider like this. Okay, if we consider like this, so what will be the amplitude of another signal to get like this? So omega will be same or not? If it is a1 omega 1 phi 1, so a2 sine omega 2t plus phi 2. Okay, so is this like this, like a1 equal to a2 or w1 equal to omega 1 equal to omega 2 and phi 1 is equals to phi 2? They are asking these relations. Okay, no need to do like this. Okay, in our class directly we know some of the Lissajous figures. Okay, so I will tell you the shortcut to know Lissajous figures. Okay, so if one signal is 2 sine omega t, okay, so this is x of t, okay, and y of t is equals to 2 sine omega t plus 90. Okay, if these two are the signals, then what we will be getting? If omega equal to 0, if omega t equal to 0, that means if theta, otherwise we will consider as omega t equal to 0, what we will be getting? We will get a straight line like this, linear, okay, or straight line we can consider. Whenever omega t is between 0 to 90, what you will get? You will get an ellipse with major axis. Major axis is in first and third quadrant. See, this is first quadrant, this is third quadrant, like that you will get, okay. So and it will be clockwise rotating. Whenever you get so omega t equal to 90 degree, so you will get circle rotating in clockwise direction like this, okay. Circle means it's not ellipse, okay, circle only you will be getting, okay. So what is the major axis? In an ellipse, major axis will be this one, okay, but for the circle we don't have any major axis, we have only radius and diameters, okay. So next, here you will be getting clockwise rotating, so between 0 to not 0, between 180 degrees to 90 degree, okay. So between 90 degrees to 180 degree you will get like this, a clockwise rotating one, okay. So next, here you will get like this, it is 180 degree. So between 180 to 270, this is 270 degree, between these two you will be getting same major axis like this. This is the major axis which is in the, okay, so this is second quadrant, this is fourth quadrant, like this, okay, second and fourth quadrant, and here it will be first and third quadrant, okay, clockwise rotating only. But here what you will get, major axis will be same like this, but rotating in anti-clockwise, same major axis like this one, okay. So and here you will be getting this one, and here major axis is this, and it is anti-clockwise direction between 270 to 0 degree or 360 degree. This is generally we used to study from these two, okay. So in the subject only we used to study about these two, okay. So but what they have given, they mentioned it is an ellipse, it is an ellipse which is having a major axis as the y-axis. So how it is possible? Is there anything possible like this? Not at all possible, okay. So I will tell you one thing, from the different options we need to check our capacity here, okay. So where which type of signal it can be possible, okay. So I have already solved, that's why I am directly giving, okay. We can think once, if both are having same magnitude, we are getting the circle like this, okay. If we don't have the same magnitude, what will happen? Instead of, for example, this is 2 and this is 1, instead of getting the circle you will get the ellipse like this. Let's try. No guess, okay, we need to try this one, okay. So not in the exam, in the exam directly we need to answer, we know already what is the answer for this, okay. So because y-axis they have aligned right, so magnitude must be, if we have to get the ellipse means magnitude must not be same, okay. So but we will see, okay, how we will be getting this signals. Let's take one example signal, from that I will explain and conclude about this question, okay. So one example it is enough to understand all the concepts from this, okay. So I am taking x of t equal to sine omega t, y of t is equals to 2 sine omega t plus 90. These are the two signals I have given, okay. So let's give something. So here x magnitude and y magnitude, when omega t equal to 0 degree, 90 degree, 180 degree, 270 degree, and then 360 degree. These are the 5 different values on same timeline we are taking, x and y magnitudes, okay. So let's take it, whenever you substitute omega t equal to 0, sine 0 is 0, okay, sine 0 is 0, and whenever you substitute 0 here, sine 90 is nothing but 1 into 2 is 2, 1 point we got, okay. So next point, 90, sine 90 is equals to 1, and sine So this is 90 plus 90. Sin 180 is equals to 0. 0 into 2 is 0. Next 180, sin 180 equal to 0. Next sin 180 plus 90, sin 270 it is minus 1. Okay, so minus 1 into 2, minus 2. Okay, so next 270 minus 1. On x-axis it is minus 1. On y-axis 270 plus 90, 360 it is 0. Last point also you will get 0 and 2. We need to put these things on our Lissajous, on our CRO screen, which will be called as Lissajous figure. Okay, so if you draw whatever figure we will be getting, that is called Lissajous figure. Okay, so let's draw this one. So first point is 0 and 2. Okay, so if anybody is new to this concept, just I am giving the reference lines. Okay, how to draw the Lissajous figure. So this is 0 and 0. Understood? This is x-axis and this is y-axis. I am taking as a square type. Okay, so this is square type, which is 4 by 4 screen we are taking. Okay, so let's take this one. First point is 0 and 2. On x-axis 0 and y-axis 2. On x-axis 0, y-axis 2. This is the point. Okay, let's take the magnitudes also. This is 2. This is minus 2. Okay, on like this only, same also. Okay, so next on x-axis 1, on y-axis 0. On x-axis 1, y-axis 0, not going anywhere. Okay, so this is the second point. Remember, okay, this is first point, this is second point. So however we are noting down the points, like that only we have to draw the Lissajous figure. Okay, so next one, 0 minus 2. On x-axis 0, y-axis minus 2. Third point. Next point, if you check, you will get here minus 1, comma 0. Fifth point again is this one. So Lissajous figure will be like this. See what we got. This is not circle, this is an ellipse it is. Okay, so ellipse. Where is the major axis? Major axis, that means wherever bigger axis is there inside the ellipse. Okay, that is the one. Okay, so this is the major axis. So see, that is satisfying. Okay, an ellipse with major axis aligned along the y-axis is observed. Okay, observed, already we have observed this one. Okay, see, this question you may not answer in the examination, but you understand the concept once. Okay, so once you learn these Lissajous figures, you should not forget about how these Lissajous figures are changing according to magnitude, according to frequency. See, for example, if frequency is different, you will get number of loops like this. Number of loops you will be getting if frequency is different. If phase difference is there, then only there will be Lissajous figure. Otherwise, if no phase difference, then straight line you will be getting. So these are all the important concepts from CRO. Okay, from CRO, nothing else they will be concentrating. Okay, there are no theory questions in the future exams. Only from the CRO, Lissajous figures are YT mode of operation or XY mode of operation, or operation of CRO or CRT. Okay, on this only there will be questions. Okay, so anyway, answer for this question is, you observe these two. Okay, frequency is same we have taken. There may be phase difference is also there. Okay, and same magnitude is not there. Okay, two signals are periodic, that means same frequency only. Okay, so with the same frequency but different phase and magnitude, different phase and different magnitude. So answer for this question is option 4. This is one of the important model, and so just understand the concepts, and in our classes already we have discussed all these concepts. With that we are adding this question also later. Okay, so anyway, next question. So that's what from the measurements. Okay, similar to this we have given all the other subjects also. Please watch all those things and it will be useful for your upcoming examinations, as I told. So don't miss the questions from some subjects like measurements. Should not miss any of the questions. Okay, so and digital electronics. Okay, digital electronics, circuits. Okay, so circuits, control systems. Okay, circuits, control systems, analog electronics. These are fixed models are there in every subject. Whatever I have written here, in all these fixed models are there. Questions will not be that much lengthy. Even though if it is lengthy also, we can solve in very less time. Okay, very rarely we will get some difficult questions. Okay, here also some difficult questions comes. Okay, but we should not miss all these things. Definitely half of the percent we can be completing from this one only. Okay, so anyway, in different video we will come up with another subject explanation. Okay, thank you so much.